here's the second part. It says, given the quadratic function in vertex form, identify the vertex. So we know from the front that the vertex is H and K, where H and K are the vertex. So my y equals a times x minus h squared plus k. Now remember, there's a sign change on the inside because y is not very honest. So when I pull this out, this becomes 6, 3. Identify. That's 7. So this is negative 7, 4. Okay? You try. Given the vertex, write the equation in factored form. So it's y equals, you're not going to have anything for a because they don't give that to you. They have to give you those. So it's x minus 4 plus 5. Whoops, don't forget the squared. That's very important. That'll cost you points on things. This is y equals x minus 19 minus 5. Don't forget the squared. And again, you try. Okay. So it says find the first and second differences decided the following chart is a quadratic function. So if you grab your handy dandy calculator, I know that this is plus 1, plus 1, plus 1, plus 1. Because you go from 0 to 1, you add 1. So you take 4 minus 3.75, and that is minus 0.25. This is minus 0.75. 3 minus 1.75 is, so that's a negative 1.25, and this is a minus 1.75 because we are going down every single time. Now we're going to subtract these again. So 0.75 negative minus 0.25. Okay, so we go back to Agile Mind. I'm in Quadratics, Past Overview, Exploring Quadratic Forms, page 1. It says, examining the data, he realizes max height is 4.9, and that was 1 second after. The max point is 1. 4.9, that's this point way up here. It's called the vertex of your graph. So he wants to, how is the vertex related in this form? So if your vertex is 1, then you have 4.9. The value of y is the same because of the k in the function rule. So that gives you h and k. Notice it's negative 1, but we pull it out as 1 because remember x just lies. Here we go. Okay. So we need the equation of this. So it's because h and k are both coordinate values of the vertex. This is called vertex form. Vertex form indicates our translations, reflections, stretches, and shrinks of the parent function. Okay. So we've already done transformations. H was a horizontal translation and k was the vertical. H goes with the x of the vertex and k goes with the y. A is our reflection, shrinks, and stretches. Okay. So it says, what is the equation of the graph in vertex form? And we already have that. So we can write it here. Y equals, go back to the Agile Mind. Whoops. That's not what I wanted. There we go. Accidentally clicked off of that. Okay, so it's y equals negative 4.9 x minus 1 squared plus 4.9. Okay? Since the graph represents the height of the soccer ball over time, what are the x-intercepts and what do they represent in the problem? Okay, so let's just go to page 4. It says take another look. What are the x-intercepts? So if you look here, it crosses the x where x is equal to 0, and then it crosses it again where x is equal to 2. Okay? Well, that's because at time 0, think about what he's doing here. He's kicking the ball, right? And it goes way up, and then it gets at its highest point, and then it goes down, and it hits the ground. Okay? So that tells me it was in the air from 0 to 2. So 2 seconds. Okay? So it says you can use your knowledge of zeros to find another algebraic relationship. Okay, so know that 2 and 0 are the zeros, so you know x minus 0 and x minus 2 are factors of the quadratic. If you don't remember how to do that, we'll talk about that Monday. Then, go to the next one, we're going to flip it over. Then, we need to stretch it up. Okay? So we found how to stretch it. They got the negative 4.9 because they used 1. And remember when you reflected it, you, let's go back, replay that. It started out at 1, 1, and then it stretched up here to 4.9. So that's where they got those. Okay? Okay, so it says, what are the zeros of the graph? Well, that was from slide 1. It says the zeros of the graph are 0 and 2. So 0 and 2. Okay? There we go. It says, what are the factors? Well, factors are where you put them back in parentheses. Okay? So that means that one of them is x minus 0 and the other one is x minus 2. It says, what do we multiply the graph by to open downward? Well, we multiply it by a negative. So we went through the animations. You can go back and play them. So it's negative x minus 0, x minus 2. And it says, what is the stretch of the graph? Well, it stretches it from here all the way up to 4.9. So negative 4.9, x minus 0, x minus 2. Because what is the algebraic representation of the function? Well, let's talk about that. Whoops. Okay. So here is our algebraic relation of our function. So it's y equals negative 4.9 x minus 0, x minus 2. Okay? The form, trying to get to the right spot. Okay? The form y equals x minus r1 times x minus r2 is called the factored form. So number 4, your blank is factored form. And the quadratic says, identify the zeros of the following functions as an ordered pair. Okay, so they want us to identify the zero. Why is my mouse doing this? It's kind of weird. Identify the zeros. Okay, so we're going to start talking about the, okay. So identify the zeros. Well, here are the zeros here. Here's are the two factors. Sign change. Coming back out. So it says identify the zeros following the functions as an ordered pair, as ordered pairs. So when you do a 0, it means that y is equal to 0. So my first one, if I change the sign, is negative 4, 0 and positive 2, 0. Okay? So you've got a couple of ways to do this. You can set it equal to 0. And then set x plus 4 equal to 0 and x minus 2 equal to 0. So you get x equals negative 4, which is where that one came from. And x is equal to 2 because I add 2 to both sides. Okay, so let's do that with this one. It says find them as an ordered pair. We're going to set things equal to 0. So if I take negative 3, x minus 2, x plus 5, and set it equal to 0. Okay. I can divide both sides by negative 3 so I can get rid of it. And then I take the parentheses and set them equal to 0. Sorry, I put an extra set in there. I really didn't need. So if I add 2 to both sides, x is 2. If I subtract 5, x is negative 5. So if you put them as an ordered pair, it should be 2, 0, and negative 5, 0. Okay? So I want you to try. You try. Remember, that is what? Write it twice. You have to write that one twice. Okay, so turn it over in the back. Vertex form is y equals a times x minus h, plus k, my fault, extra parenthesis, where the vertex is h and k. Factored form is y equals x minus r1, x minus r2. Okay. Okay. The zeros of the function, the domain values, okay, x, that cause the function to have the value of 0, which means where y is equal to 0. Okay? So it says identify the zeros as an ordered pair. So we're going to do 1, and then you're going to try the other 2. So x plus 5 times x minus 2, set that equal to 0. So it's x plus 5 equals 0, and x minus 2 equals 0. Subtract 5 from both sides, you get x equals negative 5. Add 2 to both sides, you get x equals positive 2. Write them as an ordered pair. The y's are 0, so it's negative 5, 0, 2, 0. So try B and C, because we've done this a couple times. It says, given the zeros, write the equation in factored form. Okay, so now you're going backwards. All you need to do is remember that it's y equals x minus r1, x minus r2. Remember that when you go into the parentheses with x, it's a sign change, because x is not very honest. So this becomes y equals x minus 3 times x plus 4. And do the same thing with this one. Follow your same form. Y equals x minus a negative 6, x minus 5. Okay? So you try C and D. We'll talk about it. Then it says, given the graph, find the zeros, write the function in factored and vertex form. So the first thing I need to do is find the zeros. Here are my zeros. Matter of fact, I can highlight those. 0, 0, zeros. Okay? So the first one is at 1, 0, and the second one is 1, 2, 3, 0. It says write it in factored form. So it's x minus r, so minus 1, x minus 3. Then it wants to know, well, what is the vertex? I have another color highlighter here. My vertex is right here. So it's 1, 2 for the x, and down 1, so it's negative 1 for the y. Now it wants the vertex form. So remember, it's going in, so x lies, so it's minus